Yeah, just now I said MOSFETs have characteristics just similar to the JFET, junction feedback transistors. But there are additional characteristics that make the MOSFETs very useful. Nowadays in VLSI technology, MOSFETs play an important role compared to the JFET and BJTs. MOSFETs are very popular, very useful. As a computer science or information science student, you must know what is there in your mobile phone, what is there in the computer. So these are the MOSFETs which play an important role in the VLSI. So MOSFETs, again, they have two types: depletion type MOSFET, enhancement type MOSFET. Depletion type, enhancement type. So in some of the textbooks, they might have written D MOSFET, E MOSFET. The short form is D MOSFET, E MOSFET. So better to say depletion type MOSFET and enhancement type MOSFET. Any device, first we should study the construction. Let us see the construction of depletion type MOSFET. Depletion type MOSFET. MOSFET stands for metal oxide semiconductor field effect transistor. Depletion, emptying. In Kannada, khali modu, khali ಆಗಿರೋದು. Depletion type MOSFET. Later we'll come to know why this is called as depletion type MOSFET. So the construction, this is the construction of the depletion type MOSFET. Always, unless otherwise specified, everyone selects N channel. N channel. At the end of the session, I will tell you the difference between N channel and P channel. This is N channel depletion type MOSFET. If it is N channel, always we will have P substrate, a very wide P substrate. Just opposite to the N is P. So N channel means we will have a P substrate. The N channel is always present on the P substrate. N channel is there on the P substrate. Here is the N channel. Here is the N channel. Here is the N channel. So remember, so N channel depletion type MOSFET construction, always first write P substrate. First write the P substrate, rectangular P substrate, on which write an N channel. Only from here to here is N channel. As usual, it has got three terminals: drain, source, and gate. There are three terminals: drain, source, and gate. Gate, already we have studied what is the function. Or if you want to understand in an easy way, think about your house. Your house will have a gate. What is the purpose of the gate? To control the guest. If you want those guests, you'll open the gate. If there are some stray dogs or some salesperson, you close the gate and put a lock or put a board, dogs inside. So gate is used to control the inflow and the outflow to your house. This is just similar to the gate. Gate always used to control the drain current, output current. Is it okay? Three terminals: drain, source, gate. Unless otherwise specified, always we will have N channel depletion type MOSFET. See how many participants? 37 participants. Give me some time and just take the attendance. N channel depletion type MOSFET. Always write P substrate. Now coming to the drain and source. This is the drain, N-type region. N-type region is drain. Another N-type region at the bottom is called as source. Here is the N-type, here is N, this is drain. The drain is connected to this N-type material through a metallic contact. This is the metal, the black one is the metal. We want an external lead. If you see any device, definitely it will have one terminal coming out of that device. So this is a metallic lead. This is called as ohmic contact or metallic contact, from which we have connected this drain to this N-type region. Similarly, this is the source terminal connected to this N-type region through this ohmic contact or metallic contact. So this is the drain, this is the source. Source and drain, are connected through an N channel. So here is the N-type source, N-type drain connected via N channel. All these things are present on a P-type substrate. Usually I say there are three terminals: drain, source, gate. Drain, source, gate. But see here, there is one more terminal called substrate. There is one more terminal called substrate. Yes, yes. This substrate is connected to the P-type substrate through the metallic contact. But usually we will say three terminals. Why? Because this is a substrate. This is nothing to play an important role. So usually the substrate terminal is internally shorted to the source. At the end of this session, I will show you the symbol. There easily you can make out the substrate terminal shorted to the source. Okay. So in many multiple choice question, MOSFET has got three terminals or four terminals. 3 means drain source gate, 4 means drain source gate and substrate. But usually substrate is internally shorted to the source, so we can say there are 3 terminals. I will repeat once again because welcome back once again. Internet connectivity problems, so we cannot avoid it. So once again, let us start with why less participants. 37 students are there. Yeah, MOSFET. I was talking about the MOSFET, N-channel MOSFET. Always it will have a P-type substrate. P-type substrate. P-type substrate. So gate, source, and drain. Why this is called as MOSFET, metal oxide semiconductor field effect transistor. Field effect transistor already we have discussed. Then what is this in addition? MOS. So this region is connected to the drain terminal through a metal. This region, N-type region, is connected to the source through the gate region. This N channel is connected to the gate. N channel is connected to the gate through a silicon dioxide layer, SiO2, through a silicon dioxide layer, which is nothing but a dielectric medium or insulating medium. So N region is connected. See, there is no physical connection. N channel is connected to the gate region via silicon dioxide, which is nothing but insulator. So this darker one, black one is metal M. This silicon dioxide, which is acting as an insulating medium, silicon dioxide oxide layer O. This is nothing but a semiconductor. MOS, M metal oxide semiconductor. MOS, this is nothing but a field effect transistor. Whatever the field you apply between gate and the source is used to control the drain current. I think you got the point. What is M? M stands for the metal, metallic gate. Oxide, silicon dioxide used as a dielectric medium. This is a semiconductor. And field effect transistor, the electric field applied between the gate and the source, acts as the controlling voltage to control the drain current. This MOSFET is also voltage control device. Whatever the voltage applied between the gate and the source is used to control the output parameter, the drain current. Just let us go through the theory part, whatever it's there. Let us go through this. The drain and the source, connect to the N-type doped regions. These N-doped regions are connected via N-channel. This N-channel is connected to the gate via thin insulating layer of silicon dioxide. N-doped material lies on a P-type substrate. This N-type material lies on a P-type substrate that may have an additional terminal connection called substrate, denoted by SS. So after understanding the construction, After understanding the construction, next part is to understand its operation, how it operates, how it operates. There's a box here, I don't know why it is appearing. This is the construction, this is the operation. So the same N-channel depletion type MOSFET, same N-channel depletion type MOSFET. Initially, we will apply VGS is equal to 0, just similar to the JFET operation. We will apply VGS, VGS. Here is the source, here is the gate, nothing is applied, short circuit. So VGS is equal to 0 volts. VGS is connected to ground, so 0. As I said earlier in the previous slide, the substrate terminal is always internally shorted to the N channel. Varsha H, switch off your camera. N channel depletion type. I request all of you to switch off your camera. If at all, if you want, send me a message in Edmodo. I will turn on all your uh, cameras. You can see yourself. N-channel depletion type MOSFET with VGS is equal to 0 volts and applied voltage is VDD. Positive voltage is applied. Positive voltage is applied. VDD is applied. VGS is equal to 0. This is just similar to the JFET case 1. Apply positive voltage VDD, make VGS is equal to 0. This is some positive voltage. VGS is equal to 0 and VDS is applied. See the difference? Here, battery name is VDD. Battery name is VDD. VDS is the voltage between the drain and the source terminal. Drain terminal and the source terminal. If you keep a voltmeter between the drain and the source, it gives you VDS. So what happens if you apply VGS is equal to 0 and some positive voltage? For example, 5 volts, 6 volts, 2 volts, any positive voltage. This is the negative terminal of the battery. This is the positive terminal of the battery. Negative terminal of the battery is connected to the source. This is N-type source region. N region means majority carriers are electrons. These electrons are getting repelled by the negative terminal of the battery. Like poles repel each other. So the negative terminal of the battery repel the electrons which are present in the source. So electrons will start moving upwards, start moving towards the drain region. See here, electrons are moving towards the drain region. Now come back to the positive terminal of the battery. Positive terminal of the battery is connected to the drain terminal. Positive terminal of the battery definitely will attract the electrons which are present in the drain region or which are moving towards the drain region. It attracts. So more and more electrons will reach from source to the drain region. Again, they go back to the positive terminal of the battery. From negative terminal of the battery, electrons will come. So electron flow is in this direction. Just see the cursor in which direction it is moving. Here it is shown. Here in the black arrowheads. Electrons are always moves from source to the drain. Then also you know that the conventional current is just opposite to the flow of electron current. So the electrons are moving from source to drain. The drain current flows from drain to the source, ID. ID is the drain current. Drain current is just opposite to the flow of electrons. Is it okay? This results to attraction. Okay. Here, if you apply negative terminal, electrons are repelled. If you apply positive terminal, positive voltage to the drain, it attracts. So easily electrons are flowing from source to the drain. That means drain current is flowing from drain to the source. Think what happens if you increase the applied positive voltage. Applied positive voltage. Earlier, let us say 2 volts. Now it is 3, next 4, 5. Here you have applied more voltage, more and more electrons getting repelled. So they move toward, this is the channel, they move through the channel towards end. More positive voltage exists at the drain, it attracts more and more electrons. So current increases. Apply still more positive voltage, PDS. More and more number of electrons will reach from source to the drain. So ID increases. As you go on increasing VDS, ID increases when VGS is equal to 0. So VGS is equal to 0, current will go on increasing. Case 2, let us make VGS some negative voltage, minus 1 volts, minus 2, etc. Make VGS minus volts. Here, connect a battery where negative terminal of the battery is connected to the gate, positive terminal of the battery is connected to the source. Apply negative voltage. Here it is 0. Next case, apply negative voltage. Here, apply negative voltage, negative terminal of the battery to the gate. What happens if you apply negative voltage to the gate? Negative voltage. Same VDS positive, same VDS positive, same VDS positive. So earlier electrons are flowing through the N channel happily from source to the drain. Now in between there is a gate which is having negative potential. Like poles repel each other. This negative terminal of the battery which is connected to the gate will repel the electrons. If they repel, they will move towards the substrate. Substrate. See the electrons? They are repelling from the gate region. This is a silicon dioxide layer. This is the metallic gate. This is the N channel. Negative voltage is applied, so electrons which were happily moving from source to drain now getting repelled. They are moving away from the gate region. They are moving towards the substrate. At the same time, here is the negative voltage. There are holes in the p-type substrate. The holes will getting attracted towards the channel. The holes, these positive charges are nothing but holes. They will start moving towards the channel. When holes are moving towards the channel and the electrons are moving towards the substrate, in between they will recombine. Here see, recombination process. Electrons and holes getting recombined and they will disappear. That means there is loss of electrons. They are getting recombined with the holes. Or the electrons are moving away from the channel. So current decreases. If it is minus 1 volts, current I said decreases. Think about minus 2 volts. More and more electrons getting recombined with the holes in the p-type substrate which are moving towards the channel. Still the moving carriers, mobile carriers, the electrons decreases, current decreases. Increase minus 3, minus 4, minus 5. At certain voltage, all electrons will recombine here. No electron can reach from source to the drain. The current becomes 0. The voltage at which drain current becomes 0 is called as VGS off or VP, pinch off voltage. It's because the channel is pinched off. No carriers will be there here. As you go on increasing VGS negative voltage, all electrons will move away from the channel, are getting recombined with the holes of the p-type substrate. No electrons can reach the drain, no current flows, so that voltage is called as VGS off or pinch off voltage, VP. Now think about why we have named this as depletion type MOSFET. As you increase the negative voltage applied at VGS, the electrons which are present in the channel getting depleted. In Kannada, khali aagta irutte. If you go on increasing VGS, negative voltage, this will start getting depleted. Electrons will start getting depleted from the N channel. At certain voltage of VGS, all electrons will get completely depleted. Current becomes 0. That voltage is called as pinch off voltage. Let us go through the text. The negative potential at the gate pressures electrons towards the p-type substrate and attracts holes from the p-type substrate. Holes are entering to the channel. Electrons are moving away from the channel. You can see here. This will reduce the number of free electrons in the N channel available for the conduction. The more negative the VGS, resulting in less drain current. At certain voltage called pinch off voltage, VP, ID becomes 0. If you apply a large negative voltage called VP, at which the drain current becomes 0. I hope you have understood This is an important topic. We have seen the construction, we saw the operation, now the characteristics. So if you get a question, definitely you must write the construction diagram. Construction, this is the construction. This is the working. When VGS is equal to 0, VGS is negative voltage. So after working, definitely you should represent using some graph, that is characteristics. You should represent by its characteristics. 41 participants are there. So just let me take the attendance. You need to attend the class from the beginning, not at the end. We are taking the class for your benefit. If you don't take it seriously, you will be the loser, not the institution, university, or the teacher. So this is the characteristics. If you observe these characteristics, unfortunately, if you remember, this is the characteristics of JFET. JFET, junction field effect transistor. ID versus VDS. Drain current versus drain to source voltage when VGS is constant. Gate to source voltage is constant. First one, VGS is equal to 0. There also, gate to source voltage, we kept it 0. VGS is equal to 0. When VGS is equal to 0, the maximum drain current, we call it as drain to source saturation current. If you go on increasing VDS, if you go on increasing voltage, at certain voltage called pinch off voltage, the current gets saturated. Current gets saturated. But current will not become 0. Current will not become 0, but it gets saturated, that is IDSS. Case 2, you went on increasing negative voltage. VGS is equal to -1, VGS is equal to -2, VGS is equal to -3, VGS is equal to -4. See what is happening to the ID drain current? It is getting reduced. ID here, then ID reduced as you went on applying more and more negative voltage to the VGS. Here VGS is equal to -3 volts, reduced. VGS is equal to -4, ID reduced. VGS is equal to -5 volts, very small drain current. But VGS is equal to -6 volts, no current. This is overlapping on the x-axis. Drain current is 0 at VGS is equal to -6 volts. So this voltage is called as pinch off voltage. At pinch off voltage, the current is 0. So always we apply negative voltage to the gate to source to deplete the electrons which are flowing in the channel. So the name depletion type MOSFET. If you go on applying more and more negative voltages, drain current will go on decreasing. At certain voltage called VGS is equal to VP, the current becomes 0. No rule to mention -6, -3, -2, -1. This is just an example. This is 0, -1, -2, -3, -4, -5. If you write a characteristics, you can make it this -5 or -4 or -5. Doesn't matter. But this should be 0. These should be negative values. Any negative value. Don't try to mug up these values. But remember, we should apply negative voltage to the gate to source. We never tried any positive voltage in the JFET. Any positive voltage in the JFET. But in MOSFET, let us try to apply a positive voltage. What may happen? What may happen? If you apply positive voltage here positive, source negative, positive voltage. This is the N channel, more and more number of electrons. Drain is positive, source is negative. Source is negative. I go to the previous diagram. Here, drain is positive, source is negative. Gate also we are making positive voltage. Gate to source, let us apply some positive voltage. Instead of 0, +1, +2, +3, apply positive. The electrons repelled by the negative terminal of the battery, they will move upwards. Here, positive gate voltage, it attracts the electrons, more and more electrons. Here, positive terminal of the drain, it attracts more and more electrons. Even from the p-type substrate, there are some minority carriers in the p-type substrate, electrons that are also attracted. So current increases. If you go on increasing more and more positive voltage, current increases. Usually we don't apply positive voltage. Why? Even at VGS is equal to 0, current, we are getting some drain current. We are getting some drain current. So always we should think of controlling the current. Controlling the current. How to control? Apply more and more negative voltage. If you apply positive voltage, more and more electrons will flow. The current will go on increasing. It may become uncontrollable. So here, only one example we have taken, VGS is equal to plus 1 volts. Current increases. Imagine VGS is equal to plus 2 volts, still further increases. So always we will try to control the current by applying VGS more and more negative. This is called the drain characteristics or output characteristics. Why drain? ID versus VDS. So drain characteristics. Why output characteristics? ID is the output current, VDS is the output voltage. By keeping input parameter VGS constant. This is the drain characteristics. Also, we know how to plot the transfer characteristics. Transfer means always, whenever I say transfer, it should go to your mind that one of the parameter is input, this is VGS. Another parameter should definitely be the output. Transfer means one input, one output. So input is always VGS, output is always ID because it is a voltage control device. Input is always VGS. So VGS is equal to 0. I said here draw a perpendicular line for some particular VDS. For some VDS, let us say VDS is equal to 5 volts. VDS is equal to 5 volts. When VGS is equal to 0, what is the current? IDSS are 8 milliamps. Keep VDS constant, change VGS. So VGS is equal to 0, 8. VGS is equal to minus 1. Draw a horizontal line. Sorry. Draw a horizontal line. Somewhere it meets. So here it is minus 1. Minus 2. Minus 2. I'm not perfect in drawing that system. So here, so minus 2. VGS is equal to minus 2. Here I am getting the point. Minus 3. Similarly, minus 3. Draw a horizontal line which meets at VGS is equal to minus 3. VGS is equal to minus 4. Draw a horizontal line which meets at VGS is equal to minus 4. Similarly, minus 5. VGS is equal to minus 6. It is pinch off of the 0. Now join all these points. To get the transfer characteristics. So transfer characteristics will show you how ID, drain current, behaves with the variation in the input controlling voltage VGS. Always we will try to control the current. We will increase the negative gate to source voltage so that at one point current will become 0. But depletion type MOSFET can be operated in depletion mode. Whatever I explained till now, it is a depletion mode. How to deplete the mobile carriers? How to deplete? By increasing negative voltage applied to the VGS. There is one more operation mode for depletion mode, depletion type MOSFET, that is enhancement mode. Enhance means increase. How to enhance? Apply positive gate to source voltage. If you apply positive gate to source voltage, you draw a line, the current increases. So to the right of this vertical line is enhancement, to the left of this vertical line is depletion mode. Here you are depleting the carriers, current decreases. Here enhancement. Here it goes on increase. When VGS is reduced to pinch off voltage, in this example it is minus 6. No necessity to remember it minus 6. Then ID is equal to 0 milliamps. At pinch off, ID is equal to 0. ID is equal to 0 at VGS is equal to minus 6. For positive values, here are the positive values. The positive values of VGS, the positive gate will draw additional electrons from the P-type substrate, hence ID increases. When you apply positive gate to source voltage, in the P-type substrate, minority carriers are electrons. They were also attracted and they enter the channel. So electrons increases, current also increases. So this is about the characteristics, most important, very interesting. Even if you have not understood, go through this once or twice, definitely you will understand. And also I have shared many videos of working out these devices. Very interesting, very interesting. If you have not understood after coming to the college, I will try to explain once again. Or if you request me to send an Edmodo, I will teach you once again. So this is what we discussed. Same transfer characteristics, same drain characteristics. A depletion type MOSFET can operate in two modes, depletion mode and enhancement. Depletion where current decreases, enhancement mode where current increases. First plot drain characteristics. From the drain, plot the transfer characteristics. The characteristics are just similar to JFET. The same characteristics we have written, but we don't operate JFET in the enhancement mode. Except this, everything remains the same. When VGS is 0, ID is IDSS. Drain to source, saturation current. When VGS is less than 0, ID is less than IDSS. The formula used to plot the transfer curve still applies. The same formula we have used for JFET, if you remember. ID is equal to IDSS into 1 minus VGS by VP whole square. Repeat, ID is equal to IDSS into 1 minus VGS by VP whole square. This is the formula to find the drain current. This is drain to source saturation current. Get to source voltage. This is pinch off voltage. So they will give you almost all parameters except one. They will ask you to find out the remaining parameter. So the numericals will be very simple. So I'm not solving here. Same problems are there in your textbook or the material that I have shared. So go through that. Any doubts, you can post it in Edmodo. Same enhancement mode. VGS is greater than 0. VGS is greater than 0. VGS is greater than 0. ID increases above IDSS. Still, the formula will be the same to plot this transfer characteristics. That is, ID is equal to IDSS into 1 minus VGS by VP whole square. Yeah, few more minutes. This is the complete N channel. To complete, but I will be able to complete. This is enhancement mode of depletion type MOSFET, the same thing. So this P type depletion type MOSFET, P channel depletion type MOSFET, P channel depletion. If you observe, P channel, source is P, channel is P, drain is P. But substrate is N, just opposite. Earlier drain current was flowing from drain to source, now it is opposite. Just reverse the polarities of the current and the voltages. The same characteristics, but VGS is equal to 0. Now see, VGS is positive for depletion mode and negative for the enhancement. Earlier it was in the second quadrant. Now it goes to the first quadrant because P channel, all these values are positive. VGS is equal to 0, 1, 2, 3, 4, 5, 6 because it is P channel. If you go for negative, the current increases above IDSS. That's all the difference between N channel and P channel. Here gate voltages were negative for the depletion mode in N channel, but in the P channel they are positive. So here was a negative range, here is a positive range. So the transfer characteristics will be in the first and the second quadrant. This is depletion mode, this is enhancement. Now coming to the symbols, this is the N channel N channel MOSFET, source, drain, gate. This also you can write, but very most popular, very frequently used is this symbol. This is source, this is drain, this is gate. This is substrate. See, the substrate is shorted to the source. Here the substrate is not shorted, so you can write both, but you prefer this. This is for the N channel, this is for the P channel. P channel is here, it is outgoing arrowhead. N channel, incoming arrowhead. So here see, from the gate to the channel, there is no connection at all. This is metal, this gate is metal,